to the class of physics. And here in the last class we have discussed regarding type of extrinsic semiconductors, where we have studied there are two types. One is the p-type semiconductor and another one is n-type semiconductor. P-type, n-type semiconductors can be added by doping tetravalent semiconductor with the pentavalent impurity, and whereas p-type semiconductor can be obtained by doping tetravalent semiconductor with trivalent atom or trivalent impurity. This is what the regarding basic thing about p-type, n-type, and today we will discuss the difference between those two semiconductors. So first difference is its statement, that is, here I will say n-type and here I will say p-type semiconductor. So first difference is that this can be obtained by doping tetravalent semiconductor with which kind of impurity? With the pentavalent impurity. So similarly here, this can be obtained by doping tetravalent semiconductor by, or you can say with trivalent impurity. So this is the statement, or you can say the definition of both p-type and n-type. So n-type can be obtained by doping a tetravalent semiconductor with the pentavalent impurity, whereas p-type can be obtained by doping a tetravalent semiconductor with the trivalent impurity. And next one, here you can say number of electrons much more than the number of holes, and here you can say number of holes much more than number of electrons. By the statement you can say in the n-type number of electrons is more than the number of holes, and in p-types number of holes is more than number of electrons. And here one more point we can say for this only, majority charge carriers are electrons, and minority charge carriers are holes. And here it is just inverse, majority charge carriers are holes, and minority carriers are electrons. So this depends upon the number of electrons or number of holes. Here in the n-type semiconductors, number of electrons is more, hence the majority charge carriers are electrons, and here the number of holes is more, hence you can say majority charge carriers are the holes. And one more thing regarding the energy band, here whatever atom you have added, whatever the impurity you have added, that is what the donor here, and here acceptor. Here energy level of acceptor impurity, here it is donor impurity lies just below the conduction band, and here the acceptor impurity lies just above the valence band. So there are four main differences between p-type and n-type semiconductor. So I will repeat. N-type semiconductors. First, n-type semiconductors are obtained by doping tetravalent semiconductor with a pentavalent impurity, whereas p-type semiconductor can be obtained by doping a tetravalent semiconductor with a trivalent impurity. And here the number of electrons is more than number of holes, and in the p-type number of holes are more than the number of electrons, and in the n-type, once again in the n-type, the majority charge carriers are electrons and minority charge carriers are holes, and in the p-type majority charge carriers are the holes and minority charge carriers are the electrons. And talking about the energy level, the impurity, or you can say donor impurity, lies just below the conduction band, and here acceptor impurity just lies above the valence band. So this is regarding the difference between p-type and n-type semiconductor. So next concept is PN junction. PN junction, or you can say semiconductor diode. PN junction, here we are joining p-type semiconductor and n-type semiconductor together, and where these two get joined, you can see p-type and n-type semiconductors joined, and where it is joining, that is called PN junction. See, here we cannot join, like we cannot do like separately we form a p-type semiconductor and separately we form n-type semiconductor when we will join. This process will not happen. It is not happen like this. How it is obtained is, during a crystallization of a semiconductor, both pentavalent and trivalent impurities are added, such that half of the length of semiconductor becomes p-type and half of the length of semiconductors becomes n-type. Here circular sections or circular figure is nothing but the holes. These are nothing but the holes, and these nothing but the electrons. You can see the number of holes are more here, then it becomes p-type semiconductor, and here number of electrons are more, hence it becomes n-type semiconductor. So this can be obtained by adding impurities both pentavalent and trivalent, such that half of the semiconductor becomes p-type semiconductor because of the trivalent, and half of the semiconductor becomes the n-type semiconductor because of the pentavalent. So half of p and half of n. Where these both joined together, where these two semiconductor joined together, that boundary is called the junction, PN junction. So here we can see p-type semiconductor and n-type semiconductor joining at this section, at this boundary, it is called as junction. So this is what the PN junction is. So first point is clear, PN junction. So junction or PN junction, it is the area, or you can say it is the boundary where both p-type and n-type semiconductors joined in the PN semiconductor or PN junction. Then next is here you can see in the n-type semiconductors, electrons are majority charge carriers and holes are majority charge carriers in the p-type semiconductor. Means number of electrons are more in the n-type semiconductor and number of holes are more in the p-type semiconductor. Now, due to the concentration variation, you can say here the electrons are more and here the electrons are less. Because of this reason, electrons from n-type semiconductor, because of this reason, what reason? Because of the concentration difference concentration difference, electrons are more here. Because of this reason, electrons from n-type semiconductor start crossing the junction and coming to the p-type semiconductor. So coming to the p-type semiconductor. So if, let us say that if these 4 electrons crosses the boundary and comes here, crosses the boundary and comes here, being here acceptor impurity is there, acceptor atom is there, this becomes negatively charged. It is coming here, means it becomes negatively charged part. And 1 electron is going, means 1 electron is going from donor impurity. If it is moving from the donor impurity, means positive ion is remained. Positive ion is remained, hence it becomes positive. Or I'll just mark it as a positive and negative. So this is positive, positive, and positive, and positive. Here, because of the electron migrating towards the p-type, as these holes are absorbed and becomes negative charge, negative ions becomes negative ions. Hence, positive part and negative part is formed. Near to this junction, this boundary, positive and negative is formed. How it is forming? Because of movement of electron from n to p, because of concentration reason. This process of moving electron from n-type semiconductor to the p-type semiconductor, this process is called the diffusion process. So you have to remember what you mean by the diffusion. So diffusion is a process where electrons are moving from n-type semiconductor to the p-type semiconductor. This movement is called diffusion process. Now, this is what the diffusion is. Now, electron is moving from n-type semiconductor to the p-type semiconductor. Means electron is crossing the boundary. Electron is moving. Electron is moving means there is a development of current. So here current will be there from n to p region. This current which is developed because of, try to understand, this current developed because of movement of electron from n to p. Or you can say current developed because of diffusion of electron. Diffusion of the electron is called diffusing current. Diffusion current. So diffusion current is a current which is produced in the semiconductor, which is induced in the semiconductor because of diffusion of electron. What is diffusion? Diffusion is nothing but movement of electron from n region to the p region. So these two terms we have learned here. What are those terms? Diffusion and diffusion current. So because of this movement, we can say a charge is produced, and here 1, 2, or number of the holes and 2 number of holes, 2 number of holes and 2 number of holes, 1 or 2 electrons. So here 1, 2, 1, 2 and 1, 2 and 1, 2 electrons will be there. Still this is n-type and this is p-type. Now, and 1 or 2 holes. This diffusion process initially which is very fast, and as the time passes, this diffusion process going slowly. So you can say that initially, as the p-n junction formed, initially diffusion current is more. As the time passes, diffusion current becomes lesser and lesser because of the concentration gradient. This diffusion process continues till the equilibrium reaches. Equilibrium means number of holes must be equal to the number of electrons in the p-n junction. And here you can see in the n-type semiconductor, complete positively charged ions were there, and in the p-type semiconductor, completely negative ions are there. So I can say that here positive plate and here negative plate are formed. So these two plates being positive and negative, electric field is generated. Electric field from positive to negative side. So electric field, I will mark this as E. This is E. So electric field is generated at the distance, particular distance, this distance, right? So what is this distance is? E distance on the arrow. What is this distance is? The distance this where no charges are moving. Here there is no movement of charge. In this region there is no movement of charge. This is called the depletion region. This region or this area is called depletion region. So this region where there is no movement of charge, L, where it is near to the junction. So area near to the junction where there is no movement of charge, that area is called depletion region. So this is what the depletion region, and this thickness can be measured by D, which is vary from 0.1 micron to around 1 micron maybe. So it is what the depletion region. So, and you can say that in this distance D, electric field is created by the positive and negative plates. So because of this positive and negative plates, and because of this electric field, it is acting like positive plate, and this is acting like negative. So here a voltage is built up. When fictitious voltage comes, that voltage is called as voltage barrier. This voltage barrier do not supports the flow of current, but it opposes the convection flow of the current. We will see that in the next class, maybe in forthcoming classes. Because of this voltage barrier voltage, the electrons further present here in the N region do not crosses the junction and comes here. Because of this voltage, electrons cannot move from the N region to the P region. Only some number of electrons can move. Once this voltage is built up, no further movement of the electrons is there. So this is what the voltage barrier. So in this we have studied certain points like PN junction. PN junction is the boundary formed by joining P-type semiconductor and N-type semiconductor together. We cannot form separately and join. This is the process of forming a P-type semiconductor and N-type semiconductor in single crystal by adding a trivalent and pentavalent impurities. So once the junction is formed, further process like diffusion takes place. Diffusion is the process of movement of the electron from N region to the P region. This diffusion causes some current that is called as diffusion current because of the movement of electron. So diffusion process causes current that is called as the diffusion current, and here because of diffusion, one part of this boundary forms a positive plate and a negative plate, or you can say positive ion and negative ions are collected. That forms electric field, and that generates a barrier voltage. So barrier voltage, and barrier voltage do not allow to cross further electrons from N region to P region. So this is regarding the PN junction. And this positive can be represented by higher potential, and this negative can be represented by lower potential, and this indicates the potential difference. This is what the potential barrier, that is VD. So this is voltage barrier, can also be called as potential barrier. Because of this potential barrier, electrons from N region do not crosses the P region, and this distance is nothing but the depletion region. This distance, and this is positive and this is negative. So this is what the electric field diagram. So this is regarding PN junction. So today we have studied regarding the difference between P-type and N-type semiconductor, and also PN junction. In the next class, we will study regarding the semiconductor diode, and what do you mean by forward bias and what do you mean by reverse bias. So I'll stop here. I'll be continuing in the next class, and thank you.